Doing problem 3 from section 5.2, another one of the word problems that was similar to the example problem for maximizing profit. So again, we're given the cost function, we're given the demand function, that's the price as a function of the quantity. And what we have to remember then is that in order to find the profit, we need to first find the revenue. So revenue is defined to be price times quantity. So we have the price, that's the little p times q, p times q. Distribute to q, we get this. So this, again, is the revenue function. That's revenue. And then once we know revenue, we can find profit. And again, I'm going to use the capital P here, distinguish that from the small p for price. So profit is defined to be revenue minus cost. And we have both of those functions now. We've got the revenue function, 70q minus 2q squared, minus the cost function. And be careful that you subtract the entire cost function. That means put parentheses around it, distribute the negative, simplify that. So if you do all that, you get for your profit function negative 2q squared plus 52q minus 80. So there is our profit function. That's the thing that we're trying to maximize. So if we remember from the example problem here, what that profit function would actually look like if you were to graph it, you'd have the quantity of items sold here on that axis, you'd have the profit here in dollars. And you would just notice again that has a negative intercept. It's a parabola opening down, so it's going to look something like that. We know it's opening down because of the leading coefficient there. We're trying to find the maximum profit. Really two things about it. How many items do we have to sell to maximize profit? That's the Q max there. And then we also want to find the corresponding profit that goes with that Q value. So again, as we remember, this is a critical number for that. So in order to find that, we want to find P prime. We want to find the derivative of this thing. By the way, P prime is actually called the marginal profit. We want to find where the marginal profit is equal to 0. So this is negative 4q plus 52. Okay, and then we set that equal to 0. So negative 4q plus 52 equals 0. Solving that, we get negative 4q is equal to negative 52. Divide both sides by negative 4. Q is equal to 13. So that is actually the Q max value. That's the value. That's how many we would have to sell in order to maximize profit. So in fact, in this particular problem, the way they word it is part A, we want to find the number of units that produces maximum profit. So this answer is part A. And then for part B, that's asking what is the price that will maximize profit? Well, we can find that by plugging that into here. So the little p, if you want to call that little p max, if you want to, that's what you get when you plug 13 into that price function. And when you do that, you should get 44. So that's the price that you should charge, $44 per item, whatever these items happen to be. And then finally, part C is asking us to find the maximum profit. So that's the big P, call that big P max. That would be the P value that corresponds right there. And that we get by plugging the Q value that we got, the 13, into the profit function right here. So that's minus 2 times the 13 squared minus 52 times 13, and then minus 80. When you do all that, I did that in my calculator here, you should get $258. $258 is the maximum profit, and I hope we can see that. Let me just move this up a little, make sure you can see it. $258 is your maximum profit. So we found 3 things. How many items do we have to sell to maximize profit? 13. How much do we have to charge to maximize profit? 44. How much maximum profit will we actually make? $258.